very easy for you to expose HTTP endpoints from your applications that can respond to HTTP requests. These HTTP endpoints can be set up without you having to deal with servlet APIs. Spring allows you to configure message handlers which can send messages between the components of your application, and you don't have to deal with the Java messaging service APIs directly. And finally, when you work with the Spring framework, you get monitoring support without dealing directly with JMX APIs. So, as you can see, Spring allows you to harness the functionality provided in its different modules in a straightforward manner. Here is a big picture view of how exactly the Spring framework works. When you're working with Spring, you're typically writing your code in the form of business objects that are POJOs or plain old Java objects. These POJOs, which are your business objects, will be managed by the Spring container. In addition, you might specify addition configuration metadata for your object. This can be via Java annotations or via XML configuration files. This configuration metadata will be applied to your business objects, and in the end, you'll get a fully configured system that is ready for use. The core fundamental building block of Spring is the Spring Bean. Spring Beans are objects that form the backbone of your Spring application. This can be user defined beans or beans that are available as a part of the Spring framework. The basic feature of Spring Beans is the fact that they are completely managed by the Spring framework. Their entire life cycle, starting from creation, the way they work during their lifetime, and deletion, all of this is handled by Spring. Spring Beans form a core feature of the dependency management system available in Spring, the inversion of control. Inversion of control is a process by which objects define their dependencies and an external container injects those dependencies into the object. Any Spring Bean within the Spring framework only has to state what its dependencies are. It's not responsible for creating instances of those objects. An external container will take care of this. As a developer, when you develop your own Spring Bean components, you only have to declare what your component is dependent on. You are not responsible for creating or instantiating those dependencies. In order to manage dependencies using dependency injection and the inversion of control mechanism, Spring depends on these four components: the bean, the service, the injector, and the process of injection. A bean is any object within your application that depends on the behavior of another object. A single bean can have multiple dependencies, and other beans can depend on the bean that you create. The term service typically refers to an object that the client bean depends on. The service is what exhibits the behavior that the client bean uses. The injector refers to the code that is part of the external Spring container which tells the client bean which service to use. And finally, the way the client bean, a component within your Spring application, gets a reference to the right service which has the right behavior is via the process of injection. Here is a big picture view of the modules included as a part of the Spring Framework runtime. You have data access and integration modules that use JDBC, ORM frameworks such as Hibernate. All of these serve to abstract you away from the transaction mechanics of the underlying database. You have web-related modules as well, which help you build REST services and web applications. You have modules that enable aspect-oriented programming, where you can write code to extend the functionality of existing components. You have modules for instrumentation and messaging as well. At the heart of it all is the Spring Core container, which takes care of dependency management using dependency injection. There are also a number of testing frameworks that work with Spring, allowing you to test your application end to end. As a Java developer, anything that you need to develop a fully fledged production ready application is available in Spring. You simply have to use the right component, set up the right configuration either in XML or via annotations, and you're good to go. I won't discuss each of the Spring modules in detail. You'll be encountering many of these modules when we actually build our applications using Spring Boot. But let's discuss Spring MVC briefly because we'll use that a lot. Spring MVC is the framework within Spring that supports the use of the model view controller design pattern for building web applications. The model is the representation of the data that you want to show to the user. The view is what is rendered to the user, and the controller manages interactions between the model and the view. Spring MVC uses the servlet architecture, a simple overview of which is present here on your screen. You can see that the web browser makes HTTP requests and gets HTTP responses from the web server. Within the web server, Spring MVC has a servlet program running which will look at the incoming web request and get the right handler to respond to that web request. The response handler responsible for that web request may process the web request by accessing a database, querying a database, or updating a database. Once the handler has finished processing the request, a response is sent back to the user.